Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics, then please do subscribe to my channel. So in my previous video, I had explained about the exercise 9.2 first question and example 1, which was there in the ninth chapter of 9th standard mathematics, that is on circles. So now in this particular video, we'll move on to the next questions after first question in exercise 9.2 and we'll try to solve those questions. So now we are looking into exercise 9.2. In that, we'll look into the second question. So the solution for the first question I have explained in the previous video. You can refer the previous video for first question. So now we will move to the second question. So in second question, they have given if two equal chords of a circle, so one circle is there and two equal chords are there in that particular circle, intersect within the circle. So they are intersecting within the circle only. So now you have to prove that segments of one chord are equal to the corresponding segments of the other chord. So basically here, if you are considering one particular circle like this, so we are considering one particular circle and let's say this is the center of this circle O. Here there are two chords in this particular circle, so they are equal in length. So these two chords are equal in length. So one, let's call this as AB chord and other chord we call it as CD. And these two chords are intersecting. And here you can clearly see these two chords are having two segments now. So that is, if you consider this point as E, so if you consider this point as E, here you can clearly see CE is one segment and ED is another segment. So in the total chord CD has got split into CE and ED. And the total chord AB has been got split into EB and AE. So that means here the corresponding segments of both the chords you need to prove they are equal to each other. So that is, you have to prove CE is equal to BE and you have to prove that AE is equal to AD. In order to prove that, you can join this particular E. So you can join this particular E with the center like this. So let us join this particular E with the center like this. So now here we have this point as E and we have joined E and O. So here we will now try to join A and O and we will also try to join O and D like this. So now OA and OD are radius of this particular circle. So now we have this particular diagram. So here we are considering a circle O in which AB and CD are equal chords. So here AB is one chord and CD is another chord which is intersecting at E. We will draw a perpendicular line to AB, and we'll also draw a perpendicular line to CD. So now we have triangle. So here let's name this point as M and this point as N. So let OM be the perpendicular to AB and ON be the perpendicular to CD. So let OM be perpendicular to AB and ON be perpendicular to CD. So now OM is perpendicular to AB and OM is perpendicular to CD. So, and we know that equal chords are at equidistant from the center. So that means here already OM is equal to ON because from theorem 9.5, equal chords of a circle are equidistant from the center. So now we will consider these two triangles, that is OME and ONE. So consider triangles OME and triangle ONE. So in these two triangles, so OME and triangle ONE, so here OM is equal to ON. This is from theorem 9.5 because equal chords are at equal distance from the center. So this is from theorem 9.5 and here OE is equal to OE because it acts as common side. So OE is equal to OE because OE act as common side. So OE act as common side. And here you can see that this particular angle is also 90 degree and this particular angle is also 90 degree, because we have already considered OM and ON are perpendicular to AB and CD. So here OME is equal to ONE, which is equal to 90 degree, because here OM is perpendicular to AB and ON is perpendicular to CD. So now here one right angle is getting equal to each other, and here hypotenuse is also getting equal to each other, and one side is becoming equal to each other. So therefore triangle OME is congruent with triangle ONE. This is from RHS rule. So this is from RHS rule. So therefore here ME is equal to NE. So that is this particular side ME is equal to this particular side NE. Now we have to prove MA is equal to ND also. So now we'll consider this particular triangle and this particular triangle, and this is also 90 degree and this is also 90 degree. So now consider, so let's call this as equation 1. So now we will consider triangle OMA and triangle OND. That is, we are considering this particular triangle OMA and this particular triangle OND. So in which AMO and OND are equal to 90 degree. So AMO is equal to OND is equal to 90 degree. This is because OM is perpendicular to AB and ON is perpendicular to CD. So now here we can see OA is equal to OD because they act as radius of the same circle. So OA is equal to OD because they act as radii of same circle. So they act as radii of same circle. So now one more side you need to prove which is equal to each other. So here OM and ON are equal to each other because chords are equal to each other. So OM is equal to ON. This is from theorem 9.5. So here right angle, hypotenuse and one side is getting equal to each other. So therefore triangle OMA is congruent with triangle OND. This is from RHS rule. So from RHS rule we have proved these two triangles are congruent with each other. So therefore here this particular MA will be equal to ND. So MA is equal to ND. This is from CPCT. So this we can call as equation 2. Here ME is equal to NE in equation 1. This is also from CPCT, that is corresponding parts of congruent triangles. So in equation 1 we have ME is equal to NE. So here ME is equal to NE. This is from equation 1. So here EA and ED are straight lines and MN lie on EA and ED. So ME plus MA and NE plus ND you can add together. So ME plus MA plus NE plus ND. So here ME is equal to NE and MA is equal to ND. So therefore here ME plus MA is equal to EA is equal to ME plus NE plus ND is equal to ED. So therefore EA is equal to ED. So here ME plus MA is equal to NE plus ND because ME is equal to NE and because MA is equal to ND. Here ME plus MA is equal to NE plus ND. So that means here EA is equal to ED. We know that AB is equal to CD. Both the cards are equal to each other. And we have proved that EA is equal to ED. So therefore other segment must be equal to each other because AB is equal to CD. So CE will be equal to EB. So therefore CE is equal to EB. So that means here corresponding segments of both the cards are becoming equal to each other. So that is what they had asked to prove in this second question, and we have proved that. So now we will move to the next question, that is we'll move to the third question. So in third question, they are asking if two equal chords of a circle intersect within the circle. So the same thing, whatever was there in second question, they are saying here. So within the circle, prove that the line joining the point of intersection to the center makes equal angles with the chord. So if you remember example 1, if you don't remember, you can refer my previous video. So in previous video, in example 1, when I was explaining about example 1, they had already mentioned that angles are already equal. They already mentioned angles subtended with the diameter from both the chords are equal to each other. So there you need to prove that chords are equal to each other. But here they are already mentioning chords are equal to each other. Now you have to mention that angles are equal to each other. That's it. So it is very simple question. So we can just solve this. So we have one circle like this. So let's call this as center O. And here equal chords intersect with each other. So let's call this particular chord as AB. And we'll take one more chord which is equal to AB. So let us call this chord as CD. So they both are intersecting at point E. So now here draw a diameter which passes through this intersection and the center like this. So call this diameter as PQ. So now draw a perpendicular line to AB. So now draw perpendicular line to AB and draw a perpendicular line to CD. So let this point be M and let this point be N. So now you have to prove that this particular angle and this particular angle are equal to each other. So here OM is perpendicular to AB. So this is 90 degree and here ON is perpendicular to CD. So this is also 90 degree. So now we'll just write the statements. So consider circle O in which AB and CD are two chords. AB and CD are two chords intersecting at E. So intersecting at E. Now draw a diameter. So now draw diameter PQ. Draw diameter PQ passing through E. Passing through E and the center O. Of course, diameter means it has to pass through center, so no need to mention that. But this particular diameter should pass through E point. Draw perpendicular. So draw OM perpendicular to AB and ON perpendicular to CD. So now you have to consider these two triangles. So now you have to consider these two triangles, that is OME and ONE. So now consider triangle OME and triangle ONE. Here since AB is equal to CD, which they have already given because they have mentioned equal chords. So since AB is equal to CD, OM is equal to ON. This is because according to theorem 9.5, if chords are equal, then they are at equidistant from the center. So this is according to theorem 9.5. And here OME is equal to ONE is equal to 90 degree because OM is perpendicular to AB. This is because OM is perpendicular to AB and ON is perpendicular to CD. So now we have got one right angle equal to each other and we have also got one side equal to each other. And here OE is equal to OE because OE acts as common side for both the triangle. So this is hypotenuse. So one right angle, one hypotenuse and one side are getting equal to each other. So therefore triangle OME is congruent with triangle ONE. This is from RHS rule. So this is from RHS rule. So now all the corresponding angles and corresponding sides will be equal to each other. So that means here MEO will be equal to ONE. So therefore MEO is equal to OEN. So MEO is equal to OEN. This is because of CPCT. So now here we have proved that these two chords are making equal angles for the diameter of the circle which is passing through E and O. So that statement you can write here: the line joining the point of intersection to the center makes equal angles with the chords. So that statement, whatever is there in the question, you can write here. So because we have proved that it make equal angles with the diameter, both the chords make equal angles with the diameter which has been passed from the point E. So that you can write as the final conclusion statement. So here in this particular video, I have solved the second question and I have solved the third question. So remaining questions I will be solving in my next video. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.